We're going to start today with a little warm-up. So I'm going to give you a few minutes to work. This is what we've been working on over the last 3 days. And we need to make sure that you know it, because today we're going to look at the same thing only from tables and graphs. So if we don't know this, it makes it hard to visualize. So I'm going to pause this. If you're watching the video, take time to do this and then unpause it and come back. So let's look now. I want to make sure that all of this makes sense to you so that we can move forward today with our tables and our graphs, right? So where is the particle located at 3 seconds? Where is which equation? Position, right? So you're going to find S of 3. Now you have the S equation right there. If that's S, what's velocity? S is position, velocity is 2t minus 3, and therefore acceleration is just 2. Now with acceleration at 2, what does that tell you about acceleration? It's never 0 because there's not a variable, and it's 2. Is 2 a positive number or a negative number? So acceleration is always carrying the sign of positive, right? It's nice to think about that. You don't have to worry about it if it comes up later. All right, what is the average velocity? Where do you want your average to go? Up. So what's up from velocity? Which equation is up from velocity? Position. So that tells you to use position. First 4 seconds would be S of 4 minus S of 0, because it's n minus beginning over the total number of seconds. So we are plugging into S. Why do we know we're plugging into S? Right? We're plugging into S because we want average, and when you want average, you go up. What's velocity at 3 seconds? In this case, we want velocity at 3, right? So that's 6 minus 3, which is 3 feet per second. Make sure as you use these that you are adding the appropriate units. Does the particle ever change direction from left to right? How do I know that? I do a sign chart for velocity. It has to stop to change directions, right? So I set velocity equal to 0. And what does t equal? Right? So now I have a sign chart. And of course, time starts at 0. We can't go back further than 0. If we do, we're going to get the Nobel Prize in physics, right? So I need a number smaller than 1.5, so I'm going to check 1. I need a number bigger than 1.5, so I'm going to check 2. Again, this is just a review of the last 3 days before we do new stuff. So if I plug 1 in here, I'm going to get a negative answer, right? Because I'll have 2 minus 3, so that's negative. If I plug a 2 in there, that's going to be 4 minus 3, that's positive. So it stops at 1.5. Does it change direction? Yes, it was negative, now it's positive. So it changes direction at 1.5 seconds, or 1.5, whichever way you like to say that. Now it's asking us about average acceleration. We know average goes up. So if you're looking at the acceleration equation, what's 1 up from that? Velocity. So we'll take the velocity at 4 minus velocity at 0, because it says the first 4 seconds, indicating we're starting at 0, divided by time. Time is 4. So you plug that in, and what do you get out? What is that? 5 minus negative 3 over 4, which is 8 over 4, which is 2 feet per second squared. What is the acceleration at 6 seconds? Well, there's nothing to plug into acceleration, so it's 2. And let's talk about this for a second. Now, common sense would tell me if acceleration is constant, I could have answered this question with 2 to begin with. I didn't need to do the formula. But your teacher me is mean. And there's going to come a day at the end of this unit, and I'm going to ask you to show me what acceleration is, show me both ways. So you have to be able to show why it's the same. So I want to make sure you know that work, right? Is the particle speeding up or slowing down at 6 seconds? How do we do that? We check and see if velocity and acceleration have different signs, right? Different signs of slowing down. So I have to do a velocity. Now we've already done the work for this. You already have your velocity chart. It's negative and positive. Now acceleration never stops. So we don't have a number on this chart, and it's 2. 2 is a positive number. So acceleration is always positive. So if I look right here, the yellow side versus I'll do a green side. Oh no, those could be Packer colors. I got to change that. Okay.
Miss Coughlin?
Yes.
So wait, acceleration is like always positive in like every equation, or just
No,
this?
in this one, acceleration is 2.
Okay.
Doesn't have a variable. Good question. If acceleration was 2t or had an equation, we would set it equal to 0. But this one, acceleration was just 2. So that's a positive number. It's a constant this time, only because it doesn't have a variable. That makes sense?
Yes, thank you.
Okay. So right here, our signs are different, so we're slowing. Right here, our signs are the same, so we're speeding up. And I really think y'all should get highlighters or matte pencils. If you'll color code some stuff, it'll really pull your eye to what's going on. We want 6 seconds. This is 1.5. 6 seconds would be way over there. So we are speeding up. Got our foot on the gas, right? 8 and 9, I want to make sure you know the difference between these two questions. So what is the displacement? Displacement just means where did I end minus where I began. So plug 6 into S, get an answer, plug 0 in. And I think that's 8 minus, and I think this was negative 10, and that equals 18 feet. That means I'm 18 feet away from where I started, right? Okay, now I want total distance. How do we do total distance? We've already done some of the work. So we have to start at the beginning and we have to know the end. But we've already plugged these in. We already know S of 6 is 8. And we already know S of 0 is negative 10. The other thing we have to check for is, did we stop? Now we've already figured that out, right? Up here, we figured out that it stops at 1.5 seconds. So we have to take that 1.5, right? We have to take that 1.5 and plug it into the S equation and see how big it is. So you got to take 1.5 and plug it in here. Use your calculator, right? And that comes out to negative 12.25. Now you ask yourself the question, how far did it move? I got last block's notes. All right, okay. So how far is it from negative 10 to 12.25? That is 2.25. We don't care if it's negative. It's not negative or positive because we're asking how far. Now, how far does it travel to get from negative 12.25 to 8? That's 20, correct? 0.25. So these are the distances you actually traveled. So we have to add these together. And what is that? 22.5 feet. This, I could have moved, stopped, turned around, and went back. That's why for total distance, we have to figure out the stops where the displacement is 18 feet. So I only am 18 feet away from where I started, but I traveled 22 feet to get there. Okay, so this was what we've studied over the last 3 days. This was our warm up, because today we're going to look at if I don't give you an equation, I just give you a graph, can you figure all this out? Well, we're going to see. Voila, look at these. So that's all I'm giving you is this picture, and I want you to tell me if it's moving, going left or right, and all that stuff. It's actually very easy. Okay, let's identify this graph first. That helps a lot. So this is a position graph. Now, the first thing you need to look at when you start one of these, a table or a graph, is you've got to see what they gave you. They might not be giving you position. They could be giving you velocity. So you always have to make sure you know what you're looking at. So now let me ask you this. Position is what equation? ST, correct? Position is velocity, is a ST. What is the derivative of ST? The derivative is velocity. Now tell me what the word derivative means to you. I want a 5-letter word for derivative. Slope. Slope. Now we want to think. So if you're looking at this graph and you're given the instructions that this is a position graph, if you want to answer questions about position, you just look at the graph and there it is. If you want to answer questions about velocity, what are you going to look at? The slope. Let that sink in. It's very easy to do. Let's label, of course. It's very important that you label your graph because you've got to remember what you're looking at, and I'm going to mix them up and give you velocity graphs, position graphs. So this is position. Is this in feet, meters? What's this in? Feet. This is the where is it? This tells us where it is. And what does the x-axis represent? Time. Now I'm going to label this because it drives me crazy to keep counting. Right? Can't stand it. Okay. So what do the y values on the graph represent? Well, we already figured that out. They represent position. And I didn't ask you what the x values represent, but let's write it down so we remember. What do the x values represent? Time. And you know from your work so far in science, in physics, chemistry, biology, you know that the x-axis is always time if you're dealing with time, right? Because time is the independent variable. It's going to go by no matter what. Okay, what does the slope of the graph represent? What does slope represent? Velocity. All right. When is the particle moving to the right, left, or is it stopped? Let's write down what we should look for before we try to do that. When is a particle moving right? Okay, so we want velocity greater than 0, which means positive. And velocity is the slope. So we want to do what? Look for positive slope. In other words, it's going up. If you write down what you need, this is a great assistance if you go to take a quiz, a review, or a test, right? I want you to have your notes to look at. I really want you to practice when you have a question before you raise your hand. Go to your notes and see if you've already answered that. When is something moving to the left? Yes. Sometimes we don't make the connection. Less than 0 means negative, so I like to write it down. And we're going to look for, whoops, look, I left out that K for look for. Look for negative slope. And that means my graph would be pointing down. When is it stopped? VT equals 0. What would that be? A 0 slope, which is what? Y equals a number. This is a flat line. And these are really important. We're going to move into curve sketching in our next unit. So this helps you. This is a segue into that unit. If I want to know where something is stopped and it's a position graph, I'm going to look for a flat line on the graph. I know it's stopped there. In other words, and you've done this in physics, right here it's stopped, but time is still going by, right? Time still goes by even if you stop, right? Okay. All right, now let's answer. It's right. It's right where it's going up. So I recommend you get a highlighter or matte pencils. And before you do it, just look for it. Well, that wasn't so hard. And now I'm going to look where it's going left. Right? That's where I'm going down. So here my pen moves down. Here my pen moves down. Here my pen moves down. See how nice that is if you happen to wait till Monday night to do your homework, which we won't do because we'll have time. But if you go to look at this on the review day, you can easily say left, oh yeah, it's going down. Or yellow, oh yeah, it's going right there. And then stopped, I'm going to do an orange. There we go. Does that not make it easier for you to answer questions? Yes, please highlight and color code. So it's going right when we use our X values. So from 4 to 6. It's going left when? 0 to 2, 3 to 4, and 6 to 7. And it stopped. When is it stopped? 2 to 3. What do you think? Is that easy? It's very easy if you know what you're looking for. If you don't know what you're looking for, you can't answer a single question, can you? So the big takeaway here is to look that this is a position graph. So if you try to read velocity, you've got to look for the slope, right? Okay. Where is the particle? This would be the graph, right? Because where is position? And what is its velocity? What are you going to look at for velocity? Slope. So if you'll just label that, you're good to go. So where is it at 2.5 seconds? There's 2.5. Here it is. Where is it? -1 feet or foot. What is the velocity there? 0, because it is what? It is flat, meaning stopped. Try to write these words down in your notes. The more you write why you wrote something down, the better it sticks in your brain. Get it to cross over your corpus callosum into the other side, right? Okay. Where is it at 5 seconds? So where, I'm going to read the graph. 5 seconds, it's where? 0. What is the velocity? Yes. Remember to read slope. Put these notes in there to yourself. I want you to think about something now. We've done a lot of math this year, right? Since August. When you take this next year in college, Calculus 1, you'll do our whole year in 15 weeks. So you will already be doing this by October. So you want really good notes to yourself, because you are my calculus wizards, right? Yeah, you are. And now you're all thinking you want to go back and retake physics because it's easy. All right. Now I got to trick you. Yeah, this is the same picture I just gave you, but what does our label say? Yes, it does. Look at this. Well, this is now a velocity graph. If this is a velocity graph, yes, look at you guys. Therefore, slope is acceleration. I swear, I have all wizards in my class. It's kind of fun. It's practically like we're at Hogwarts. And this is Hogwarts, y'all are wizards. Okay, so if this is velocity, then this is velocity. And this is his feet meters, what it feet per second. And of course, what is the x-axis always going to be on these? It's got to be time. Because everything moves according to time. Your car drives time, right? You know you like to measure how fast can I get from 0 to 60? 4 seconds. I don't know, I just made that up. What's a good speed from 0 to 60? How long should that take? But what's a good time? 3 seconds? It's good time, right? See, you understand acceleration and velocity and time. All right. What do the y values on the graph represent? Velocity. X values, time. We cannot get away from time, right? When we deal with particle motion, we're dealing with time always because the clock ticks. What does the slope of the graph represent? Acceleration. Y. Yes. Excellent words. If you write them down, it's even better. You know, research says that does make it stick. And derivative means slope. So in this case, if you want to read acceleration, you got to read the slope. If you want to read velocity, you just look at the graph itself. So when is a particle moving right? Well, let's write our reasoning down first, then we know what to look for. We already wrote this down. When VT is greater than 0, it's left when VT is less than 0. It's stopped when VT equals 0, right? That means positive, that means negative. Whoops. But on our last one, we had to look at the slope. What do we have to look at this one? Because this is a velocity. When is velocity positive on this picture? Yes, so you're looking for above x-axis. And it's negative when we look at below x-axis. Write these rules down. Then when you go to do your review, you're like, I got all the rules. And when is it equal to 0? On the x-axis, right?
Miss Coughlin.
Yes, ma'am?
So wait, how come for this one, like, it has to be above or below? Just
Because this is a velocity graph. So velocity is not the slope. Velocity is a graph itself. And this graph is positive here and negative here. Right? When you're up top, you're positive number, and when you're below, you're a negative number. So we're actually looking at the picture itself because this is labeled as a velocity graph. That make sense?
yes, thank you.
Okay. All right, so we're going right. Again, you know I don't want, this gray doesn't work for me. It all looks the same. I want to color code it so I know what's going on. So I'm going to say it's right when it's above the x-axis. I'm going to go label those. Look how easy that is. Now I can see exactly when it's moving right. And now I'm going to say, when is it going left? When it's below. So here. It's going left. And then I also want to know when it stopped, right? So, yep, I'm going to put a dot. So if I take 5 seconds to label this graph, now I don't have to stress out with which gray line ends where, right? It's all colored for me. So right goes where? It's easy to do, 0 to 1. And 5 to 7. Isn't that much easier than stressing out and trying to remember? Just write your rules down and then color the graph to match. You're good to go. It's left from 1 to 5. Also, if you look at this next October, you'll be able to say, oh, yellow is right. Why is that? It will help you. It stopped at what? X equals 1, 5, and 7. Any questions over that? Take a second to look at it. Take a second to absorb what we just wrote down and process that. We don't have to hurry. You know you love being here. You don't want time to go too fast.
So we don't put the stop points. We don't put those as like actual points. We put them down as x equals 1.
Yeah, because it's you don't have to write 1, 0 because the zeros indicated if it stopped velocity 0. All right. Now comes the question. Can you read this graph? What is the particle's velocity and acceleration at? So velocity, I'm going to put a note to myself. Look at graph. And I'm going to put a note for acceleration. And what am I going to tell myself with acceleration? Look at slope. It's easy, right? Okay, at 2.5 seconds, that's right here. What's the velocity? -1, right? I mean, like there's no work to do once you color your graph in. Acceleration, the slope. Okay, its slope is, acceleration is 0. It's a flat line. What's the velocity at 5 seconds? 0. What's the acceleration? The picture's the same, yes. And that's why you've got to be diligent. Always mark down, I was right, label your graph. You've got to pay attention to whether it's a velocity graph or a position graph. Okay. This one's a little harder. When is the particle speeding up? When is a particle speeding up?
And no, they have the same sign.
Same sign. So VT and AT, same sign. So that means it's going to have to be positive. So I'm going to write down some rules here. So above the x-axis and positive slope. Or I could be below the x, wait, I forgot the E for below. Below x-axis and negative slope, right? That would work. When is something slowing down? VT and AT have different signs. And what would that look like? That would be above x-axis and negative slope, or below x-axis and positive slope. Then they're the opposite, right? Because it's negative, positive, positive, negative. Okay. I would just run down the graph from the beginning. Okay, this first yellow part, it is above and negative. What's above and negative? Slowing down or speeding up? So 0 to 1, slowing down. Now, what about 1 to 2? It's below and negative. So what's it doing? Speeding up. Now, from 2 to 3, what's happening? Is it speeding up or is it slowing down or is it constant? From 2 to 3. Well, it doesn't have acceleration. So can the signs match? So we don't have anything going on there, right? We're constant. We're not speeding up or slowing down. Now, from 3 to 4, right here, what's happening? We're below the x-axis, which is negative, and we've got a negative slope, so the signs match. So we are speeding up. Now, what are we doing from 4 to 5? We're below, which is negative, but we have a positive slope. Slowing down. Now, from 5 to 6, we're above, which is positive, and we have a positive slope, so we match, so we are speeding up. And then from 6 to 7, we're above, which is positive, but our slope is negative, so we're opposite signs, so we are slowing down. This one had a lot of changes because we were going. You wouldn't think you could get that many answers out of there, would you? Not too bad, right? If you have all of your things written down, this shouldn't feel hard. You just need to practice with them. One more little thing we're going to do. We're almost done. If you can believe I would let you go this or let you work on homework this long. Just one more little page. And my font is big, so this is really short. What if I didn't give you an equation and I didn't give you a picture, but I gave you a table of values? Could you answer some questions? Now notice on this one, the first one I'm giving you is position. The second table I'm giving you is velocity. So we have to pay attention to that. So if this is position, how would I read velocity? What is velocity? The derivative, and the derivative is the slope. Right here, if these numbers are showing velocity, what would the slope be? There we go. We want to always connect the derivative to slope. Okay. Estimate the velocity at 1 second. Well, you said velocity is the slope. How can I find the slope at 1 second? Of course, slope is y minus y over x minus x. Now, what numbers? I'm going to show you 3 different ways. Notice the key word. What does that mean? Estimate. Can I get slightly different answers? I am. So let's see. What if I use those? Then I'm going to have what? 11.5 minus 10 over 1 minus 0. Well, what if David said, no, I don't want to use those and I want to use these? Well, then we'd have 12.6 over 11.5. Sorry, what did I just say? 12.6 minus 11.5 over 2 minus 1. And what if Burke said, no, those are on the edge, so I want to use those 2 points because one is in the middle. And he said, I'm going to take 12.6 minus 10 over 2 minus 0. Let's figure those out, punch those in and get answers. Come on, go, go, go.
Miss Coughlin,
Yes, ma'am.
could you just like put the points like in in the data table in the calculator and then get the equation, or no?
You could, you don't need that because we're
Okay.
looking for the slope.
Okay.
So this is what? 1.5 over 1. So that's 1.5. This is, what is this one? 1.1. What is 12.6 minus 11.5? What did I do right there? That should say minus. And what is this? No, I just can't write. 12.6 minus 11.5 is what? 1.1? 2 minus 1 is 1. 12 minus 11. That's okay. You could switch them, but you'd have to do both. This one is what? What's 12.6 minus 10? 2.6 over 2, which is what? So estimate the velocity. Would either of these answers, any one of them be okay? Are they all good? They're all good. Your thing to remember, if you're looking at a table and you need the slope, you have to choose 2 points and find the slope, right? Okay. When does the particle change direction? What are you looking for there? Yeah, so look here. Let me erase this so it's clear. I don't want to be pointing at lines. Okay. So I'm going from 10 to 11. I got bigger. Well, it might not tell us where it stops because this is just points. It might stop at 1.34 seconds. We don't have the whole picture, but from 10 to 11 is going up. 11 to 12 is going up, but then what's 12 to 11? It's going down. So approximately 2 seconds, or I could say between 2 and 3 seconds. Either one of those would be an acceptable way to answer that question about when it changes direction. I can see it's getting bigger and now it's started to get smaller. I might not see a 0 on there because they don't show me every point, right? Are we okay? Do you need to think for a minute? All right. Now velocity. This is a velocity graph. What I see is velocity. The slope is acceleration. What's the slope again? If I'm given individual points, I just use that slope, that formula, right? That's slope. Okay. When is the particle at rest? Tell me in words before you give me an answer. When is the particle at rest? When what? So when would this be? At t equals 3 and 9. Now these are in minutes. Usually we're dealing with seconds. All right. When does a particle change directions? Well, we have to see where it stops and see what happens. So let's look at this velocity. Velocity is a 1, then 0, then -2. So it's positive, 0, negative. Did it change directions at 3? Yes, because it was positive, right? I'm up at 1. I stop.
I was thinking it was position.
That's hard to do. This is velocity, not position. So you know what I would do for velocity? I would start looking at this. That's what's important, right? It's velocity. So velocity is positive, and I might even say here, stop, because I have to stop to change direction if I'm in a straight line motion. So I'm positive, I stop, and now I'm negative. So did I change direction? Yes, right, at t equals 3. Now here I'm negative, I stop, and I'm still negative. Did I change direction there? No, right? Just t equals 3, that's it. All right, what direction is the particle moving at 7 minutes? Left or right? It's negative at 7 minutes, so that would be left because it is negative. Approximate the acceleration of the particle at 2 minutes. Well, 2 would be right here. We don't have 2, so we'll use 1 and 3. So acceleration is the slope. I'm going to take what? 0 minus 1 over 3 minus 1, right? Time is your x. So that is -1 over 2. And that is Are those okay? Are we good? Any questions? That's it.